An effective service robot must be operable by any user. Therefore, its interface should be as natural as possible for human cognition. Here we propose a system that is able to describe general video sequences using natural language. Our system consists of an encoder-decoder deep recurrent architecture that is based entirely on the GRU paradigm, unlike the state-of-the-art approaches which rely on the LSTM unit. This makes our model smaller and faster, without affecting its performance. Given a video sequence, descriptors for each frame are extracted using the ResNet 50 and the C3D CNNs to capture both appearance and movement. These features are then passed to the video encoder. The encoder consists of two GRU layers. The first layer is a boundary-aware GRU, which automatically changes its temporal connection when the scene changes. The output of the encoder is a fixed-size vector representation of the video. The decoder outputs a natural language description by generating the most probable word at each time step, conditioned on the representation provided by the encoder and the previously generated words. The decoder stops whenever an end-of-sequence tag is generated. We trained and test our system on two benchmark datasets: the Microsoft Video Description Dataset and the Max Planck Institute for Informatics Movie Description Dataset. Our method achieves a performance that is comparable to the state-of-the-art approaches in terms of both quantitative metrics and qualitative results. We report the performance of all methods using common natural language processing metrics, and to assess the qualitative performance of our method, which is of interest to the end user, we compare it to the most similar baseline Datasets LSTMs. To test the applicability of natural language video description systems to service robotics, we collected the ICRA video description dataset. The videos were recorded using an HD camera and the built-in low-definition camera of an Ankit's Cosmo robot, and they depict a wide range of typical application contexts. We trained our model and the LSTM-based baseline on the two benchmark datasets and used our dataset for test only. Both methods perform worse on this dataset compared to the benchmark datasets. This suggests that overfitting is a major issue for these algorithms. However, our method outperforms the baseline in all four metrics, showing its superior generalization capability. This aspect, in particular, makes our approach appealing for service robotics applications.